Right, so moving on, let's start. So for the first question, what is the web messaging app the employee used to talk to the threat actor or the attacker? So for this one, we'll be checking the users. So the key thing here is to check the Windows push notifications, the one appearing here, somewhere here, the notification, Windows notifications. So to do that, so we only have one user here, which is the Omen user. So probably this is the victim user. And then let's go to the app data, roaming, Microsoft, then Windows. Mm, where is that? Windows. Let's see. Right, so I think it's the wrong path. So app data, local, Microsoft, and Windows. Then yeah, notifications. Right, so we'll be inspecting the WPN database.db or the Windows push notifications for any notifications related to messaging app. So the likes of Skype, um, Zoom, Teams, and others, right? Discord, name it. So let's try open this using our SQLite database. So what we'll do here is let me just close the others, copy the path, and we will be using this one. So you can download it. It's a portable app. You can download it. Just Google it, and you can download it. Many download sites. Of course, you have to check it's legitimate or malicious website. Okay. So let's open that up. Open that path and point it to the WPN database. Open. So here we will be browsing the data. So go to the browse data tab. We're not interested in the database structure this time. Okay, so okay, my VM just slowed down a bit, so let's wait for it to load. Alright, load it up. Take care what happened to our recording. Okay, so we will be going through the browse data. So we're interested in the table contents to find the answer for this one. So we're interested in the notifications table, and you check the payload column. You'll be able to find it somewhere around here. So yeah, Telegram, uh, notoriously used by hackers and threat actors alike. Uh, Scroll further down and you will be able to see this our project template test.zip. So interesting with this password, which actually gives us the answer for 1 and 2. As you can see here, number 1, that's how we got the Telegram, and the 2, the password for the zip file. Awesome. It's an interesting one. So what domain did the attacker use to download the second stage of the malware?
So for this one, we will follow the attacker chain. Remember, we have the file name of the sus supposed malicious file that will be downloaded. So we'll follow the chain. So it will be downloaded for the victim user, which is Omen. So the most logical path will be the downloads folder. And sure enough, we found this project template test.zip. And as you can see here, it was extracted by the victim user, or perhaps the attacker by the attacker. And inside this, we will see this extracted file. So let's go inside. So there's two docx file and a shortcut or a link file. So it's worth always checking if that link file is actually pointing to a valid document or used alternatively, or let's say it's abused. Okay, it's abused actually by attacker, or it's actually being used to execute something else. So how will we find that out? So for this one, let's open a command prompt in this directory, and we'll be using a tool called LECmd. So this is actually a link file parser by Eric Zimmerman. Very fantastic tool. It allows you to rip apart the contents of the link file, LNK file. So let's see the options here. Uh, Available options. Okay. So how to use it? You have to give it a switch of -f and then the file name, or a -d for a directory. So that's how. So there's an example usage here. So now we will uh, give it an input for that link file that we found. So what's the file name? Template. So it's template. Okay. Oh, sorry. Forgot the -f. Oh, I did have the -f. LECmd. Oh, sorry. Typo. Alright, as you can see here, it's now parsing the contents. There's a lot there. It's able to rip it out in 4.9 seconds. And if you're gonna do it manually, you'll you'll be having a hard time. So now, let's see here. It's interesting. It's not pointing to a valid document, and as you can see here, the arguments, it's actually executing a PowerShell. So this, my friend, is one of the TTP how LNK files is being abused. All right. So see here, we're interested with the domain, and as we can see here, there's obfuscated function, which seems to hide that domain that it will call back to. And somehow we can see an obfuscated domain here. Alright, seems like it's written backwards. So what we're gonna do is, if you know how to do PowerShell function, you could actually decode this and run this function, maybe up to here. So don't worry if you don't know how to do PowerShell coding. There's actually online sandbox for that. So we will be using PowerShell sandbox. Okay, bear with me. My BM is quite slow. Alright, so PowerShell sandbox TIO. So this is what I used. There are many actually. So just go to that website. Alright, try it. Yeah, and then just go to the PowerShell, and then just paste the code. This is the code, right? Then just try to run it. Where's the run? There's one. We'll try to run that function in the PowerShell context. And as we can see here, Missing URL. Okay, let me see. Let me just double check. Alright, so let's see. Let's try to find where did we went wrong. Function. Okay, where did that function go? Oh, right here. Function. Yeah, maybe up to here. Copy. And then go back. Let's try again. PowerShell. Please bear with me. OP, PowerShell. Right here. Alright, let's try again. Because we missed the other parts of the function. There. So, yeah, the function was executed successfully, and we can see here permission denied to this domain. So, that's how we found the domain. Of course, you can run it in a PowerShell, but I just show you there are other ways. You can run it directly in a PowerShell console. Alright, so that's how we found it. Right, for this next one, so what is the name of the command that the attacker injected using one of the installed LOL apps, so leaving off the land apps on the machine to achieve persistence? So when you try to Google for LOL apps, it actually comes up as the first entry. So LOL apps. So these are the leaving of the land apps being used by the attacker to achieve persistence. So the first one is actually the green shot. So yeah, so where can you find it? It's actually commonly found in the app data, then green shot. So okay, so we'll go back to our image here. So omen, app data, roaming, and true enough, there's a green shot folder here. So this is the one attacker used for persistence. So there's an ini file here we can open with Notepad++ to view the contents. Um, just give it some time to load. Alright, and once inside, the interesting part here, somewhere at the bottom, external command right here. So if you could see this command, mspaint, there's an interesting command here. So that's actually the answer here, right? And then there's a follow-up question in the file. What is the complete path of the malicious file the attacker used to achieve persistence? So of course this command doesn't make sense, but if you'll follow the ini file down there, this is actually a path parameter. So if you follow the command line, so there's actually a path here, this one, which points to omen update local temp template.link. So that's the persistence, right? So amazing, eh? Amazing TTP, right? So that's actually the answer for this one. And true enough, if you follow this path in the victim's computer, the image that we have, so there's actually a persistence drop there. Okay, maybe it's not captured by the image. Oh, sorry, because it's mounted on my disk. Sorry for that one. So if you follow that, just follow the path here because this is mounted on my forensic machine. So it's not the exact path. Rather, uh, where did I copy? Omen. Sorry, short-term memory. Starting with the omen. Oh. So if you're going to inspect it, so just paste it from here, of course, and then to the temp, just to prove to you. And there's a template that link here. There, you see, it's dropped there as a persistence mechanism. Hope it makes sense. If not, replay the video. Okay, so we've answered up to question 5. Number 6, we're nearly there. So what is the name of the application the attacker utilized for data exfiltration? Okay, so for this one, if you're not familiar with the artifact, this is called the shroom, or what you call that again, shroom. It's a background activity. Shroom. So stands for System Resource Usage Monitor. So it monitors usages of the app in the back end. For example, how much you have used Edge to transfer and receive bytes. So it's actually a good artifact when you're inspecting exfiltration cases to prove what app has been used. It also has battery usage consumption, wherein you can see if the laptop, for example, for a laptop, if it's using an AC or a DC, and other interesting bits there. So if you're not familiar with this, we're trading this one. There's actually many useful articles explaining Shroom. So if you're not utilizing it in your forensic arsenal, this is a very, very good artifact to get familiar with. So anyways, we'll showcase how it can help us in forensic investigation. So where can you find it? So let's go back. So I actually open it here in my other folder. So in the forensic image, you can find it in the Windows System 32 and then SRU path. And it's actually the SRUDB that artifact. So in processing it, it's always a best practice to copy it on a separate location to make sure it's writable because we will be processing it. So in this case, I will write it or copy it in a downloads folder, replace the files. Okay, so now it's written here, and we will open another command prompt here, and we will be using the SRU-ECMD. Oh, sorry, shroom-ECMD. Shroom-ECMD. I spell it right? Oh, yeah. So this one, the shroom-ECMD. So another fantastic Eric Zimmerman tools that helps us rip apart the contents of uh, this one, and it's best viewed using a timeline explorer, because timeline explorer again is another Zimmerman very, very cool artifact. Allows you to open CSV files, even large CSV files up to 500 MB with such ease compared to an Excel, Microsoft Excel. So I'll show you later. So how to use it? This one, just give it a switch of dash F, and then give it the shrudb dot srudb dot file, and then dash dash csv, and then the folder location where you want to put the output. Okay, without further ado, let's do that. So sruecmd. Oh, sorry. We could probably copy it from ecmd, from ecmd dash f. Oh, sorry, dash f srudb there, and then dash dash csv, and then we can actually point it same folder. Do we need a double quote? Yes, we need a double quote somewhere like that, and then C users there. Execute. Processing. Give it some time. Right, and it's able to process it. Fantastic. And now let's go back to that path. So as you can see here, there's a couple of CSV files generated. And as I mentioned earlier, there are a couple of interesting bits that Shrum contains, like the app resource use info, network connections, network usages, push notifications is also here. BFU prob, app timeline, energy usage, right? The one I mentioned, if it's using AC or DC. So we're interested in this one, the network usages output. So as you can see here, the icon is now defaulted to use Timeline Explorer. All right, so it's a CSV. Of course, you could use Excel, but if you're a forensic hater, it's cooler and it's faster to use Timeline Explorer, right? I'm not sure if you agree, but that's what I use. So let's see. Oh, I have it open here already. Right, give it some time. My BM is catching up with the multiple applications opened. Okay, it's here. So we're interested in the, oh, it's already sorted. So we're interested in the byte sent with the highest one because we're dealing with exfiltration. So those are the most possible candidates. So if you sort it in the reverse or descending order from highest to lowest, it will actually give you the prime candidate, which is anydesk.exe. All right, that's actually our answer. And as you can see here, you have seen how powerful Shrum artifact is because of the amount of useful info it will give you or insight when dealing with investigations like this. Oh, anyways, this is quite taking some time. Yes, exit. Please go back to the previous window. Okay. So that's actually our answer for this one. Anydesk.exe. And now what is the IP of the attacker? So since we know that the attacker used Anydesk, so we will follow the Anydesk trace logs or the log files of Anydesk, which is called trace files. So let's see. Of course, the path we already have the path here. User omen desktop Anydesk.exe, but I think for this one, hang on. Okay, but of course for this one, there's another roaming folder for Anydesk. App data, roaming. Yeah, just like Greenshot, there's a roaming Anydesk, and as mentioned earlier, there's an AD trace file, ad.trace. So you could open it with Wireshark or Notepad++, and we're interested in the address. Okay, you can find all in current open. Okay, let's give it some time to load. And there, we found his one, anynet.relay, which give us this public IP 77.232.122.31 over port 3998. Is that the one? Yep. So there you have it, guys. Very interesting Kraken KeyLogger case. Hope you had fun and you hope you have learned a lot from this one. I was refreshed as well with the many artifacts. Of course, if you are a forensicator, you have to sharpen your skills every now and then, or it will rust out. All right, so see you on the next challenge.